So as an example, let's look at the Gemma solar project in Andalusia in Spain. That part of Europe is the sunniest in all of Europe. So mirrors reflect the infrared and the visible light from the sun to that central black part of the tower. Now cold salt has been pumped up and heated in that black part of the tower, and hot salt descends, and this hot salt is used to generate steam in a steam generator, which then spins a turbine in the electrical generator, and then that electricity is finally passed to a transformer and is distributed around that part of southern Spain. And at every stage in the process, energy is lost, mostly wasted as heat. The electrical wires have a little resistance, so they get warm. There isn't perfect insulation on the hot salt container. And the steam turbine, it can't be 100% efficient. That would violate the laws of physics. So a year or two ago, the IB asked about coal-fired power stations. If I remember correctly, it was 5 points, and you had to name 5 places that reduced the overall efficiency. So I've tried to make this quantitative. I put numbers in. The green numbers are ones I actually looked up or I could find on the internet. So let's see what the overall efficiency of this coal-fired power station is. If I start off with 100 units of energy, then I'm only 95% efficient with the mining. 5% of the energy is kind of used up or lost in the mining process. 98% for transportation. Notice that I'm multiplying those numbers together, and it doesn't actually matter the order that you do that in. 98% converting water to steam. Steam turbines are about 42% efficient. Electrical generation is 99%. I looked that up. Transformers are 99% efficient. And transmissions about 90% efficient. So overall, we put 100 energy units in, and I've only got about 33% of the energy units out. So it's 33% efficient overall. Did you know you could buy Apple calculators? I tried to sell this to the kids because they're Apple nutters here. I much prefer Android.